Hi, welcome to this video. Are you tired of LLMs or large language models hallucinating or being limited to their outdated training data? RAG or Retrieval Augmented Generation is the solution. But how do you actually build one? In this hands-on tutorial, we are showing you the easiest way to architect a powerful RAG engine from the ground up using two of the industry-leading tools, LangChain and OpenAI Embeddings. We will also use a vector database called ChromaDB. Before we begin, what is RAG? RAG is an architectural pattern that improves the capability of large language models by grounding its output in an external, verified, and up to date knowledge bases. So, with a RAG system, when a user asks a question, the RAG system sends that question to a knowledge base and gets the relevant documents that are related to that question. And it then augments the question with this retrieved documents and sent it to an LLM. The LLM with the context in the retrieved text will be able to answer the question. So without further ado, let's dive in. In this video, I'm going to follow a notebook which is hosted in my GitHub repository. I'm going to share a link to this notebook. You will also require the requirements.txt file to set up the virtual environment. So I recommend you downloading these two files. So I'm in my working directory and I have downloaded the two files, the notebook and the requirements.txt file. So the first thing we need to do is to create a virtual environment. We are going to use the package manager called UV, which is a fast alternative to pip. To create a virtual environment, you type UV venv venv. That will create a virtual environment called venv. We are going to activate it by typing source venv bin activate. Next, we need to install the required packages which are listed in requirements.txt. To install these, what we are going to do is type uvpip install -r requirements.txt. You can see how fast it installed. I also need one more package, so I'm going to type uvpip install notebook. So that's now done. So I can fire up my Jupyter server now by typing Jupyter notebook. So now I have the notebook open. The first thing we need to do is to replace the default SQLite 3 engine with the PySQLite 3. And this is not always required, but in some systems, if you use the default SQL 3 engine, it's going to throw an error with ChromaDB. So that's now done. The second thing you need is to have your API key from OpenAI and then set up the environmental variable. You can do it by writing this command, these two commands. I have done it already, so I'm not going to do it. The next thing we need is to have a local knowledge base. So typically it's some kind of a company document, or it could be documents that are related to customer or business. In this demo, we are going to use a novel called Crime and Punishment. So what I'm going to do here is I'm going to create a directory called data, and then I'm going to download this file in text format and save it into that directory. So now that's done. And if you go back to your Jupyter notebook, you can see that the directory is created now, and it should have the file inside. Next, we need to set up some directories. So this is the location of the file that we just downloaded and also the file extension. And now we can get into building the vector database. First thing, we are going to load the file that we downloaded, and we are going to use a directory loader from LangChain. So now it's executed and we get a confirmation that one document is loaded. The next thing we need to do is to split the data into smaller chunks. We can do that with a text splitter. We are going to use recursive character text splitter from LangChain. When we instantiate, we can specify the chunk size, the overlap between chunks, and so on. And then we run this method called split documents. And when we do that, we can see that the document is split into 1720 chunks. Next, we are going to embed this data. So this data is still in the form of text, and we are going to convert them into vectors using OpenAI embeddings. And then we are going to store it in a DB, and the DB artifacts are going to be stored in a directory called Chroma, and the collection name within the DB is going to be books. So we are specifying these details and also instantiating the embedding function. And now the actual embedding and storing of the artifacts and the DB. This is going to take a few seconds. Now that's done. Now we should have a directory called Chroma in our working directory. So let's see, let's try refreshing. And yes, we do have. Now we can go back. Now that we have created our database, we can check it. One thing we can do is we can ask a question that are related to the document that we used and see whether we are getting any relevant document from our knowledge base. So what we are going to do is we have a query that is defined here, and we are telling DB to send 3 top document that has some relevant information with this query. For that we set this parameter and as 3, and we are instantiating the vector store and specifying the persistent directory, which is same as the directory that we defined here. We also specify the collection name and the embedding function, and then we do a similarity search. And the results are stored into a variable called results. I haven't run this cell, that's why I get an error. So the results of this similarity search are going to be stored in a variable called results. We can look through it and then print the content. When we do that, we get these top results. So we can see that it says that this character, so if you look into it, you can see that this character rescued 2 little children. So it has the answer. So it looks like this similarity search worked. So this is all good. But what we really need is that we need the LLM to come up with an answer, not 3 different documents. So for that, we are creating a RAG engine. We are going to import a few libraries. We are also setting the vector store as our retriever, meaning whenever we have a question, the documents will be retrieved from this vector store after running a similarity search. We also define a template, and then we also define a chat model, which is going to be, we are going to use ChatGPT 3.5 Turbo. We also instantiate a text string output parser, which is going to parse the output from the LLM. We have the prompt, we have the chat model, we have the parser, we have all the building blocks. We just need to chain them. So the RAG chain is now defined. Now we can test it. So this time when we invoke the RAG chain and we pass the question to it, it should give an answer. So let's see, and it looks like it's correct response. So again, what happened is when we asked the question, queried the database, and it got these documents back because according to similarity search, these are relevant, and these documents along with the original question in this template form is sent to the LLM, and then LLM generates a response based on that. One thing we want to make sure is that the RAG system doesn't hallucinate. Meaning, if you have a question that is not relevant or to the document that you have or the knowledge base you have, it shouldn't generate any response. So for that, we define a different query. So it says that I don't have the information to answer the question. And that's expected because the knowledge base we have, it doesn't have any information about the 6th president of the US. So in this hands-on tutorial, I showed you how we can build a RAG engine using tools like LangChain, ChromaDB, and OpenAI embeddings. I hope you liked it. If you like it, give it a thumbs up. Consider subscribing to my channel. Thank you.